and you're going to see me like on the board or maybe on assignments, abbreviate that. Parallel line, well, if my pen will work, cut by a transversal. So if you ever see that, that's what it stands for. Parallel lines cut by a transversal, okay? So when we have this, obviously we have to have parallel lines, okay? These are not marked in the pictures. We're assuming, I'm telling you right now that these are parallel, but really you should look for markings, or you should be told in words in your instructions, given that the following lines are parallel, yada, yada, yada. Okay. But parallel markings actually look kind of like tick marks, where the lines have the same number of them, but they're arrow shaped instead of just straight. So they could have two of the parallel markings. As long as they have the same number, they're marked parallel. Okay, they could just have one arrow marking like this. Okay, or it could be on the other end like this. It doesn't matter where it shows up. If two lines have those markings like that, that's how you know they're parallel, or you're told in words in the problem that they're parallel. Okay. Now there's three things I'm going to teach you to look for when you have the two parallel lines cut by transversal for determining angle measures. Because when you have this, you have two intersections. I'm going to actually start with this picture on the right, the one that says acute and obtuse. These are all the same picture, but they have different wording under them. Acute and obtuse. I think this is the most obvious one to most of you. You've got an intersection at the top, an intersection at the bottom, right? So we've got 8 angles created. Okay, 4 at the first intersection, 4 at the other. Of these 8 angles, all of these angles are either acute or obtuse, aren't they? Okay, so I'm going to put an O or an A for acute or obtuse. So this top left, oops, I guess I need a pen to do this. This top left one is obtuse, right? Okay, and next to it is acute. Under that is obtuse. To the left of that is acute. And at the next intersection, same thing. Obtuse, acute, obtuse, acute. Do y'all agree?
Yes, I agree.
Okay. Now, when I say that's the most obvious, I mean, that's why. It's just, does it look bigger than 90 or does it look less than 90? And the thing is, when we have parallel lines cut by a transversal, all 8 of these angles are going to have one of 2 possible relationships to each other. Okay, we're going to talk about that today. Okay, so underneath here, you can see it says which angles are equal, and then it says which angles add up to 180. It's because if you pick any 2 of these 8 angles created, those are the only 2 relationships they can have. They're either going to be supplementary or congruent. So if you can just identify if it's an obtuse or an acute angle, you'll know. If you pick 2 obtuse angles, they're congruent. If you pick 2 acute angles, they're congruent. If you pick 1 obtuse and 1 acute, they're supplementary. Does that make sense? Okay. Now, interior and exterior refers to the parallel lines. So I'm actually going to highlight here. If you have colored pencils or something to shade in, you can. If you don't, maybe just shade one and not the other. Okay. But interior means in between the parallel line. So when we talk about interior angles, this is what we're talking about. So there are 4 angles that are interior. These 2 at the top intersection and these 2 at the bottom intersection. That is the interior, inside the parallel lines. Okay, and then exterior is exactly what it sounds like. It is outside the parallel lines. So these angles out here and here are your exterior angles. I'm going to add of the parallel lines. So interior or exterior of the parallel lines. It's always in comparison to the parallel lines. Are you in between them or are you outside them? So far, so good? All right, and then the last one we're going to talk about is numbers. A lot of times when you have this, the angles are going to be numbered like in all of these images down here, or they're going to have numbers like an angle measure, okay? And if they have a number for an angle measure, all you need is one and you can get all the rest. So let's pretend we are told that this angle in the top right is 30 degrees. What can you tell me about any other angle there?
Left is 150.
They're either going to be 30 or 150. They're either going to be the same or they're going to be supplementary. Can you tell which ones should be 30?
Yeah.
Which ones? The ones that look acute. Now, besides just looking acute, at the same intersection, what are these that are across an intersection from each other called? They are congruent, but what's the word for the relationship? Vertical. Okay, so the angle vertical to that 30 is here. Okay, those are vertical angles. Okay, now I don't know the names of the relationships of those angles up here to these down here yet. You're going to learn those today, but you do know which ones are acute down here, right? So these should be 30 as well. And then all of the others should be 150. All the obtuse angles. Now, the obtuse angle relationship to the 30, like these that were right next to each other, what is their relationship? What was the, so these across the intersection or vertical, what are these next to each other? No, 150 and 30, they're not going to be congruent. They're different measures. They're supplementary, but there's a special relationship. But when they're next to each other and they form a line, linear pair. Okay, so if they're next to each other, they're adjacent and supplementary. We know they're a linear pair, right? So that's how I knew that this was 150. Because if I knew that this was 30 and this is next to it and it forms a line, they're a linear pair, so they must add to 180. Same thing with the 150 below it here, because they're on this transversal line together, aren't they? Okay, so a couple different angle relationships that we talked about back in unit 1 that you need to remember: vertical angles and linear pairs. Okay. All right. So let's talk about the different angle relationships. Okay. Here we're just going to do, you can highlight, you can list, however you want to do it. Okay. I'm going probably to do, I'll just do arcs. Okay. So you said that if this was the 30, that this one also would have been 30 here and here. So you're telling me those four angles are all congruent, right?
Yeah. Yeah.
Okay, so I'm going to say angle 2 is congruent to angle 3 is congruent to angle 6 is congruent to angle 7. So those four are congruent. Then the others, I have to put a different number of arcs on them, right? Because they're not the same as the blue ones. Okay, so the red ones would be angle 1, angle 4, angle 5, and angle 8. Okay, which ones will add up to 180? Okay, so there are a lot of sets of supplementary angles here. So let's just name the ones that we talked about first up here at the top. We said if they're together on a line, they're a linear pair. So 1 and 2. I'm just going to write it as plus. Is angle 1 plus angle 2? That would equal 180. What else? Good. 2 and 4. What else? Yeah, 1 and 3 or 3 and 1. It doesn't matter which order you write it in. Good. 5 and 7. I heard 5 and 6, and I think I heard 7 and 8. One more.
6 and 8.
Good. All right. So do y'all see all the different possible? Now that's at those intersections. That's not all of them. That's all of them that are within the same intersection as each other. Yeah, because they're at a different intersection. But didn't we say over here that they would not be the same? One's acute and one's obtuse. So we could say 3 and 5. 4 and 6. Good.
1 plus 3 plus 5 plus.
Now we're only doing pairs, only 2 angles at a time. What else?
6 and 3 and 5 and 4. Or could you?
Say that again.
6 and 3.
6 and 3.
Yeah.
Well, Nick, see how 6 is acute and 3 is acute? Those are going to be congruent, not supplementary. Those are one of the ones over here that are congruent. Great, guys. I know some of y'all are talking about it, but let's stop the conversation for a minute. Let me bring you back. Okay, so over here, we listed all the ones that were congruent to each other in blue and all the ones that were congruent to each other in red. So essentially, aren't we making all the different possible combinations of blue and red angles over here? Y'all see that? Okay, so I don't know that we've listed them all yet. Let's see. So 2 and 1, 2 and 4, 2 and 5, 2 and 8, right? 3 and 1, 3 and 4, 3 and 5, 3 and 8. 6 and 1, 6 and 4, 6 and 5, 6 and 8. 7 and 1, 7 and 4, 7 and 5, 7 and 8. You don't have to list them all. If you get the idea, okay, I'm just gonna put etc. Okay, because there's a lot of combinations of angles here that are supplementary. Do y'all agree? Okay, I just want y'all to understand that they don't have to be a linear. These that we listed were all linear pairs, which are definitely supplementary. But that's the thing. They don't have to be a linear pair to be supplementary. We can start doing these other combinations with angles at different intersections. All right. So now let's talk about what these different combinations of these angles are called. So this is our new vocabulary now. Okay. We said what interior and exterior meant. Okay, we said that interior and exterior refer to the parallel lines. I need the side conversations to stop. Thank you. Okay, so when we say interior or exterior, again, we're referring to inside or outside. I'm going to remember what color I did. Interior for paint. Okay, so oops, I wanted that to be a highlighter. Interior is inside the parallel lines and exterior is outside the parallel lines. Okay, so the word alternate means opposite. Okay, so alternate interior angles, the alternate is referring to the transversal. So I'm going to make my transversal, I'm going to make it a little bold so it stands out, or you can go over it and highlight whatever you want to do. This is my transversal. So when I say alternate or same side, I'm referring to the transversal. So are they on the same side or alternate sides of the transversal? Okay, so alternate interior means that it has to be inside the parallel lines, because that's what we said interior means. So inside the parallel lines Okay, and then alternate means that it's going to be on the opposite side of the transversal. Okay, so in between the parallel lines, there's only these four, A, B, C, D. Okay, and alternate sides, A and D, we know are congruent. Those are both acute. Okay, and then B and C, bless you, those are both obtuse. So these are my two sets, okay, my two set of alternate interior angles. So the big thing here is that they are congruent to each other. You need to write the word congruent. If you forget what that symbol means, write the word congruent. Okay, but these are your two sets, A and D and B and C, okay, in this image. They are on alternate sides of the transversal and they are inside the parallel line. So alternate interior. Some people ask, well, wouldn't A and B be alternate interior? Yes, A and B are on alternate sides, and yes, A and B are interior, but they're not congruent, are they?
No.
A is acute and B is obtuse. Alternate interior angles are congruent to each other. So they have to be at different intersections here. Okay, so A and B would be a linear pair. They would be supplementary. So far, so good? All right, alternate exterior. So again, alternate sides, opposite sides of the transversal. That's what the alternate means. And then outside the parallel lines. Okay, so outside of the parallel lines. So that's your, and I don't know why I'm not highlighting it up here. So these are outside. These were inside. These were interior. Now we're talking exterior. So alternate sides and outside the parallel lines, that would be A and D. See, these would be obtuse. Okay. Or B and C. These would be the acute. So those are my pairs or my sets of alternate exterior angles. So alternate interior, alternate exterior. They are also congruent. So far, so good?
Yep.
All right. Next one is same side interior. So again, we're talking interior. So in between the parallel lines. So these angles in here are are interior angles. But now we want same side of the transversal. So angles that are on the same side of the transversal would be A and C and B and D. Now notice A and C are not congruent, are they? I'm not going to mark them congruent. I'll just put the same color markings. So angle A and C are same side interior. They are not congruent. What are they? Yeah, they're supplementary. They add up to 180. Okay. And then the other set would be the B and the D. Those would be same side interior angles. They're not congruent. They add up to 180. One's acute and one's obtuse. Now, I'm not really sure why I got these notes from our team. One of our other teachers shared the notes. I don't know why they don't list same side exterior angles here. So I'm going to add it just underneath here. I don't know how much, is there much space on y'all's? Is there a little margin or something you can write in? There's no margin? Is there any space on the back? Okay, well, on that graphic on the back, it is marked. So I'll just talk you through it here. there's same side interior and then same side exterior. I guess we can just do it on the same picture. I'll just highlight. So the oops, it's supposed to be a highlighter. These would be, why is that not a highlighter? I literally had a highlighter. These are exterior, right? Why are you not highlighting the whole angle? Come on now. Seriously? Stop the side conversations again. So I've highlighted exterior. So I'm just going to put this down here, I guess. Okay, so you can have same side exterior as well. That is also a relationship that you should know. So same side exterior, I'll number these. Since we used A, B, C, D, I'll put 1, 2, 3, 4 on here. So my same side exterior would be which pairs, which sets there are on the same side and are in the exterior of the parallel lines. Not 1 and 2 are not on the same side of the transversal. The transversal is this red line I've outlined. So 1 and 3 are on the same side of the transversal, and then they're in that green highlighted area. They're exterior. So it could be 1 and 3. And what else? What's the 2 and 4? Okay, so this is what I had you add on right here. Okay, same side exterior. Those are also supplementary, and you can tell angle 1 is obtuse, angle 3 is acute. Those are not congruent. Same side exterior are also supplementary. They add to 180 as well. I just don't know why they didn't list this here. Okay, so just add that little bit. All right, now, last but not least, the angle relationship, the new vocab that you need to know is corresponding angles. So corresponding angles, I think these are actually the easiest. Corresponding angles have the same location, the same position. There's 2 intersections. There's the top intersection and there's the bottom intersection. So when I say they have the same position, I'm saying A is the top left angle. What's the top left angle at the bottom intersection? E. So A and E correspond. They are corresponding angles. Okay. B corresponds to what? F. Top right to top right. Good. Okay. G corresponds to C. Bottom left to bottom left. Okay. And then get another color here. How about it's orange. H to D. Those correspond to each other. Okay, so corresponding angles are also congruent. Okay, so corresponding angles are congruent as well. Okay, corresponding angles are at the different intersections, but same location. All right, how do we feel about all this new vocab? Do we feel okay?
Yep.
So alternate and same side refer to the transversal. Interior and exterior refer to the parallel line. All right, let's flip it over. Okay, there is at the bottom here, it's kind of, I mean, if you want to color this, you can, but it used symbols so that you didn't have to color, so that you can see all the different relationships, okay? The only ones that are 180, that equal 180, are same side interior or same side exterior, okay? So same side interior and same side exterior, add to 180. All of the other angle pairs alternate interior, alternate exterior, corresponding, and vertical, okay, those all are congruent. Okay, so this is just a reference image. If you want to color code it, you can. It's just there to put them all together in one image. Okay, so the last thing up here that we want to talk about, I referred to at the beginning, I said you don't have vertical angles and linear pairs. Guys, please stop having side conversations when I'm trying to teach the whole class something. It is rude. Thank you. Vertical angles and linear pairs come from Unit 1. Okay, we talked about those in Unit 1 and what their relationships were. Okay, and they're listed here, so you can color code or you can mark them how you want, but you have to remember vertical angles are across from each other at an intersection. Okay, they are congruent to each other. Okay, so there's 4 different pairs of vertical angles here: A to D, B to C, E to H, and F to G. Okay, so those are all vertical angle pairs. You don't have to have parallel lines and transversal to have vertical angles. Vertical angles appear at one intersection. You don't even need the second intersection to have vertical angles, right? So this is not something special with parallel lines and a transversal. Vertical angles happen at any intersection. Okay, linear pairs, same thing. These happen at any intersection. They're going to be at the same intersection. Okay, you don't need parallel lines to have this. So A and B, A and C, C and D, B and D. And then same thing down here. We listed all of those on the front when we listed over here. We were listing linear pairs because we knew those were supplementary. We knew those added to 180. Okay, so this is just a refresher from Unit 1. Okay, vertical angles and linear pairs are at the same intersection. You don't need parallel lines, just an intersection for these two relationships. The only new relationships are those on the front. Do y'all feel okay about them? Okay. All right, so y'all have a practice in Delta Math. It should be active. I'll go double check that it's active. Okay. Let me stop this recording.